Your chat is set to me, and let's go ahead and get going. So yesterday we talked about the theory, the continental drift hypothesis. So the idea that the continents have been moving around the Earth, but we established that what we see is the continents, but it's the tectonic plates themselves that are moving. Okay, so the idea is what is allowing these continents to move, which really we're asking what is allowing these tectonic plates to move. Okay, so when we talk about seafloor spreading, okay, on Pear Deck, I am going to change the slide. So let's go ahead and fill in our notes for seafloor spreading. Okay, so it says a mid-ocean ridge is a chain of submerged mountains that run through the center, that should say of. It wouldn't be a Mrs. Kennedy lesson if there wasn't a typo. Okay, of the Atlantic Ocean. Okay. And then it says as tectonic plates move away from each other, the sea floor spreads and magma fills the gap. Okay? And then last but not least, as new crust forms, the older crust gets pushed away. Okay? So this picture up here is definitely a better drawing than my doodle right here in the middle of your paper. So on the ocean floor, we have at the fault, at the boundary of two tectonic plates, there's a convection current running underneath the crust in the asthenosphere. Okay? That movement is going to send those two tectonic plates moving outward from each other. Okay? When that happens, a giant gap is not just going to continue to be created. Once those tectonic plates move away from each other, magma from the mantle fills that gap, and then it solidifies. Okay? So as it continues to get pushed away, the farther you get away from a mid-ocean ridge, the older that crust is going to be. So brand new crust right at the mid-ocean ridge, and then the farther you get out, the older that crust is going to get. Okay? So let's first start with, and we're going to do a whole bunch of writing right here in the middle. Doesn't really matter the colors, but make sure you do this organized because there's going to be a lot of labels. Okay? So just the way that this picture up here is labeled, the mid-ocean ridge is right where that crack between the boundary is. Okay? So we're going to label the same thing here. So right in the middle is going to be our mid-ocean ridge. Okay? Right here in the middle is where that mid-ocean ridge is going to present itself. Okay? As the currents in the asthenosphere continue to move, and it's going to push those layers apart, or the crust apart, okay? And then this down here is going to be our magma. It's kind of hard to write on that ink. Lack of friction. Science. Okay? So we have magma here. So then here's a question for you. open up your chat feature. If I were to label this crust right here, what kind of crust is this going to be? There's two types of crusts. If I were to label this crust at a mid-ocean ridge, what kind of crust would it be? Be specific, what kind of crust are we going to have? If it's an oceanic, if it's in the ocean, mid-ocean ridge. Okay, so oceanic crust is going to be our answer. So it's going to be really tiny, but I'm going to write it in there. Oceanic, and we're going to say lithosphere. Whew, that's tiny. Okay. So then if this is the lithosphere, go ahead and, oh, they did pick up my garbage, you guys. I thought they picked it up like super early this morning. There they are. Doing their job. All right. Anyway, I forgot what I was talking about. Okay. If this is the lithosphere, okay. We're getting it back. If this is the lithosphere, what is this underneath where the magma is? What layer is this? Think about it. If we're using the word lithosphere, what would be the next layer underneath the lithosphere? Put that in your chat. Put that in the chat. Still there. Very good. So it's going to be the asthenosphere. I'm going to write mine in red because it's magma. The asthenosphere. Remember, it's like a glass of ice water. When you if you were to shake your glass, the water would move, which makes the tectonic plates move as well. Okay, so this is your asthenosphere, which is where the currents are that move those tectonic plates. Okay, so we have our oceanic lithosphere. We have our asthenosphere, which is where the magma comes from when it's going to rise. Okay? So, another thing that I want to ask you is, what is the age of rock that is found right here? Think about how we describe the layers of the earth when we go down. We have blank on top and blank on the bottom. So think here, what is the age of rock closest to the mid-ocean ridge? What is the age of the rock closest to the mid-ocean ridge? A couple ways you can say it. The garbage person's still there. Makes me feel like something's wrong with my garbage. Ooh, nice, nice. Newer, newest, youngest, young. Perfect. So now we're kind of switching gears with where we're talking about age. You are going to find the youngest, crust, the youngest lithosphere closest to that mid-ocean ridge. Okay? Because that's where that new crust is being formed. Okay? So then if I were to draw an arrow outward, what would I put here? What description should I put here? Okay. If the crust here is the youngest, as I go outward from the mid-ocean ridge, the crust is going to get blank. Nice job, Michael. Nice. Very good, Misha. Nice, nice. Older, 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 older. Very good, very good. Beautiful. So it's going to continue to get older. Okay. So then we have one of our think about our I can statements from yesterday. Explain how seafloor spreading provides a way for continents to move. Okay? So imagine that there was a continent, you know, here is your fault line, your boundaries. Okay? So both of these are two different tectonic plates. If there's a continent sitting on top, as it continues to get pushed outward, that continent that we see is going to continue to move. Okay? So the reason that seafloor spreading provides a way for the continents to move is because it's constantly moving the tectonic plates away from each other. Okay? When those tectonic plates are being moved away from each other, and this has to be a very specific answer. Think about your I can statement number 3. When seafloor spreading occurs, what is created? When seafloor spreading occurs, what is created? Be very specific. Again, look at I can statement number 3. Very good, Olivia. Nice, Delaney. Oh, it's going too fast. Nice job. Very good. So, new oceanic lithosphere is created. Okay? So, I want you on your picture here, I want you to put a star. So, right at that mid-ocean ridge. On that mid-ocean ridge, so what do I have? We're going to write sea floor spreading creates new oceanic lithosphere. Super important. Seafloor spreading creates new oceanic lithosphere. If the tectonic plates did not move away from each other, it would not give the opening for that magma to rise and then solidify. Okay? So, there is one more thing that I want us to put in our notebook, and then we will be done for the day. So, if I were to do you notice how seafloor spreading is S, F, S? Okay? Seafloor spreading is going to describe these motions, okay? So I'm going to put an S, F, S. Seafloor spreading is going to represent, okay? And what is a name for the direction that the tectonic plates move at a mid-ocean ridge? It has to start with an S, though. What do the tectonic plates do? Go ahead and drop that in the chat. Very good. So I had sideways, slide, separate, split. You guys did a great job. I'm going to do separate. Okay. Is separate A-R-A-T-E or separate? Separate, I think. All right. So it's the tectonic plates are going to separate. Okay. Once the tectonic plates separate, something with an F. What could I put for F? The second thing that happens. the tectonic plates separate, and then, what do you think? Go ahead and write that in the... So this right here is going to kind of give you... actually, read your notes. So it says, as tectonic plates move away from each other, the seafloor spreads, which is what we have separate. And then what do you think the F could stand for? Ooh, nice, Luke. Awesome. It's going to fill. And it's going to fill with magma. Okay? Now, the next word I have used a couple times in just my vocabulary. The tectonic plates separate, magma fills the gap, and it blank. Starts with an S. What does that hot magma do when it cools down? What is that called? Starts with an S. Nice, nice, nice. Very good. Solidify. So, it's going to separate, fill, and solidify. Beautiful, beautiful, beautiful. Okay? So this is seafloor spreading. Seafloor spreading is what allows those continents to move away from each other because the tectonic plates are being pushed out. Magma fills the gap. It solidifies, which creates new oceanic crust. Okay? So that is seafloor spreading. Tomorrow, what we're going to do is we're going to talk about the pattern that is created during seafloor spreading. When we talked about magnetic fields and when we talked about our I can statements, you guys made an inference that it would be a change in pattern from the magnetic minerals. Okay? So, with that being said, we are going to be done today, and I am going to give you a exit question. Okay? So, I'm going to do it from, who knows, maybe one. All right, here's what your question is. It might be a little bit lengthy of an answer. It says, I want you to describe how seafloor spreading occurs. Okay, I want you to write that. Now, whenever you are done, you may log off, but I want you to say bye out loud, please. So hit your space bar, say bye, and then you can go when I say bye back. But you need to put your answer on first. Describe seafloor spreading.
Bye.
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 Bye, Kate. Bye, Sid.
Bye.
Bye, Hayden.
Goodbye.
Bye, Summer.
Bye.
Bye, Anthony.
Bye. Bye.
Bye, Misha. Bye, Delaney. Bye, Maddie.
Bye.
Bye, Olivia. Faith.
Bye.
Bye, Blake.
Bye.
Bye, Joel.
Bye.
Bye, Alyssa. Bye, Sarah.
Bye.
Bye, Sam.
Bye.
Bye, Morgan. Bye, Michael.
Bye.
Bye, Alex.
Bye.
Bye, Ava.